Okay, thank you very much. Yes, I'd like to talk through, give you a little bit of background information about the ETI and, as Philip said, the current call that we've got at the moment. First, I'll just mention who we are at the ETI, because many people may not have come across us. The ETI was set up just over 4 years ago as a public-private partnership, and it was really looking at trying to address the challenges that the UK faces in terms of meeting its climate change targets. So the ETI, as I say, is a public-private partnership between UK government and the 6 industrial companies that you can see here. We have funding of potentially up to £60 million per year, and what we're looking to do is accelerate technologies that can cover the whole energy system, so both in terms of improving energy usage and in terms of energy generation. We're around doing projects that are looking at demonstrating system-level demonstrations of technologies. So we don't do fundamental work, we do very much later technology readiness level, to use the jargon, demonstrations. And really, alongside that, we're looking at developing knowledge, helping inform regulation, and really, at the bottom, helping enabling the deployment of low-carbon systems. We do 2 things. First of all, we do a system-level strategic analysis, so look at trying to understand what technologies do we need when. And I'll talk a little bit about ESME, Energy System Modelling Environment, that we use, which is a model that we've developed to help understand what scenarios there might be in 2050 that can achieve 80% CO2 reduction. And then the right-hand side is looking at setting up a small number of large-scale projects which will help create commercial confidence in technologies through system-level demonstration of innovative technologies. So ESME, I mentioned, it's a national energy system tool that we've developed that helps us understand and look for a low-cost solution. We've used ESME, and this is one of the outputs where we've looked at one of the scenarios that there might be in 2050. And I'll stress that ESME looks at a whole range of different costs, implementation scenarios and so forth. So if you like, what we're looking at here is one snapshot of what the energy system might look like in 2050. If I just sort of pick up a couple of key points here, you can see at the top there, the sort of on the right-hand side are some of the blues, which are offshore and onshore wind. You've got the big yellow bit in the middle, which is nuclear, but there's a whole series of things that rely on CCS, not just fossil fuel generation, but things like production of hydrogen, use with biomass, and treating industrial emissions. So CCS is very important. And this just shows you why it's so important in terms of what the range of total system cost is. One thing ESME can do is says, if you've got a technology, what does it cost? How much more does it cost if you take that technology out? And the 2 key technologies are around how we use biomass and how we use CCS. And each of those, if you didn't have either of those, it would cost something like £40 billion a year more in the UK energy system. So that is why we're very interested in CCS, and particularly the CCS in combination with biomass is very important. Again, just to say why that's important is that it potentially creates a negative CO2. So you're actually using biomass, which is removing CO2. You're then taking CO2 out and burying it. So I won't go too much detail here, but we do a whole series of projects, from knowledge building projects right the way through development and demonstration. We have a couple of large capture projects that are typically over £20 million. And I'm going to concentrate today on the project that we're looking to, we're just launching at the moment in MMV, or rather the call that we're doing. We've been looking at MMV for a little while, but what's been informing this is a project that we've looked at the overall capacity, storage capacity in the UK. We completed at the end of last year the so-called UK Storage Appraisal Project, which was looking at to get an overall estimate of CO2 capacity in the UK, looking across all the potential depleted oil and gas reservoirs, saline aquifers and so forth. And I'm not going to go into detail of that today, but if your eyesight's very good, you can see we found something like around about 70 or 80 billion tonnes of storage capacity around the UK. And to put that in perspective, we need something like about 15 billion tonnes to be able to store capacity over the next 100 years. So really, that project has provided us a platform, and we're currently doing a lot of analysis work to understand what it means in terms of CCS rollout. So moving on to the MMV project, which is what we've got now. We've covered a lot of these already, so I'll go things fairly quickly. But just in very simple terms, there's three different ways you can deploy MMV technologies. One is the so-called deep focus technique. So this is being able to see through kilometres of rock, and we're talking about these stores between 1 and 4 kilometres below the seabed, and that's particularly things like seismic technologies. You can put something down a hole, so you can drill a hole, or you might have an existing hole, and you can put a whole range of different instrumentation down there. And finally, you could do so-called shallow monitoring techniques, where, as Owen said, you go around effectively sniffing for CO2 actually at the seabed. And all of these are complementary techniques. And we completed a study in the middle of 2010. It was done for us by BGS. And is Kerry Vincent here? Yes, hello. Kerry was involved in producing this project, and we looked at a whole range of different technologies and where the needs were. And the real conclusions of this study is that if you look at deep focus techniques, so these are a critical part, but they are fairly mature techniques. There's a lot of investment going in from the oil and gas industry. Downhole monitoring tools, again, there's been a lot of work done, and we had a look at these very carefully, but we didn't really find anything there that said this is something where the ETI can really make a difference. So we focused our call in on the shallow monitoring techniques. They're less mature and not proven, and we think there's a real opportunity. So the reason we're doing this is that its needs has been identified by the regulator. It's something that there's a lot of capability in the UK and a significant skill set that we've got. As Owen said, it applies across the whole range of CCS product, from the initial baseline studies, injection and post, and it's suitable for a whole range of store types. And really, one of the key issues around this is trying to get a very wide aerial coverage. So what we're looking for, as I said, ETI is looking at large-scale system-level projects. We're effectively looking at some people to come to us and provide us with a proposal for a complete monitoring system. So we're not focusing on any one measurement technology, but we're saying, can someone put together a system that will enable to do this monitoring in the sediments and the overlying water column? Primarily, we're looking at it as the early stages for detecting and investigating store leakage and its sources. Because we're looking for something that we believe is going to be needed by the second half of this decade, we want it to be proven to first-of-a-kind level. So our focus is on getting a technology, or a system, I should say, that will be able to do things for real as some of the projects that we talked about earlier come on stream. And it's got to be able to meet the regulatory requirements to do that. And again, picking Owen's point up, it's got to be cost effective and cover the whole range of storage. So the sort of thing we're going to looking for is something that's going to first of all say, well, what is the specification of this? We don't want to come and say, we're going to use technology X, let's see if it works. We want to say, if we're going to measure, what she said, 2 tonnes a day of potential migration out the storage site, what's that going to look like by the time it comes out of the seabed? What sort of measurement requirements are you going to have? How are you going to deploy it? We're then going to be looking at the latter part of the project is effectively going to be designing, building and testing in an offshore environment, probably involving some form of controlled leakage of CO2 in the shallow subsurface. And as I say, we're looking for a single project, and we're looking to invest something like £5 million in the successful project. I was going to change this, and it said capabilities required, which sounds a little bit, how should we say? Prescriptive, that's the word, thank you. But these are some of the sorts of capabilities we think that the consortium is going to need. First of all, we need to think beyond it. How is this going to end up getting used? And maybe it's going to be something like an offshore services company that's ultimately going to want to use something like that. They're going to need to understand this issue of subsurface and marine modelling. So what happens between the storage site and the actual surface, and what's going to happen in the marine environment. Maybe a future storage operator might have some interest in it. How are we going to deploy it? Say an automated unmanned vehicle or ROV. Critical point, sort of I was picking up from the last call. How are you going to look at the instrumentation, the integrator, and analyse the data? How are you going to pick that needle out of a haystack of information? Because there's going to be natural variation going to be going on in CO2. How are you going to detect that leak? And finally, looking at understanding what the regulation is. So I'll just finish off and say, where's the timetable? We're in the middle of the call at the moment. The deadline's the end of June, with a deadline to submit, intention to submit at the middle of June. We'll then move into project detailing and negotiation, and we're looking to get things on contract to start the beginning of next year. Again, if I can just sort of say, the ETI, the way the ETI works, we use the expertise of our members. We work very closely with our project members, and we're looking to not fund in the traditional sense, but co-invest with people that are looking to develop a system like this, and we'll be looking to work together very closely with the successful consortium. So if you're interested, speak to me today. If you don't catch me today, contact us through that general number, ccs@eti.co.uk. Okay, thank you.